Hello everybody, this is a little lesson on function notation and intersections, and a lot of this is going to have some things where you might want to use a calculator. So if you don't have a calculator, you might want to grab one of those first and press pause. As you come back to this, I'm going to do a few problems. I'm going to have you press pause and try a few problems on your own. And I'm going to start with this middle one here. I guess we'll call it like problem 2 or whatever. And what I'm looking for here is solutions. And this is a really good day for me to teach in class if it works out. But just because I have you thinking about this versus you just plotting through a video and trying to just write down notes as fast as you can. But think about, what does solutions mean when you think about two graphs and a solution? What does that mean? Well, what it means is the point of intersection. When you have graphs, this is a solution because this is where that graph is equal to that graph, right? This point right here is a solution because it is where this graph equals this graph. And you can have more than one solution, right? So as I write down these points, I would probably write down for this one, look, this is -1, right? Look at how it's labeled. So this is negative like 0.5. I would say it's about a little before that. I guess -0.5 is close enough. But if you had -0.6, you know, that's pretty legit too, right? And then my y value is a little above it again. I'll say it's, you know, it's about just about halfway there, so I'll say 0.75. You know, if you said 0.6 to 0.8, anything in that range would be okay with me. And then for the other point, well, that's pretty easy. That's exactly 1, 2. Right? And it really is as easy as that. So take a minute, press pause, go try these other two problems, right? The first problem and the third problem on this page, okay? Go.
I think I'm good.
All right, so for this one, I've got -2, right? I'm going to go up 1, 2, 3, 4, 5. Well, of course, because that line is denoted as 5. 6, 7. Well, then that's it. -2, 7. And you can see that line will keep kind of going. That line will keep going. There's no second point of intersection for this because really a line's only going to have one point of intersection with anything else. It should only go through it once unless it's not a function, of course. If we look at the third one here, it just negates what I said. Right? Because look at it, it's going through twice. Why? Well, because it's going through at the right point. So it is possible to get more than 1 point. Is it possible to get more than 2? I don't know. Think about that. Maybe we'll come back to that. So you can see the points right here and right here. And I'm just going to kind of round these to -2, -1.5, and to like 6.8, I guess. I don't know. It's real close to 7, but it's not quite 7. I don't know if I would even like you to put 7, but if you put anything from like 6.6 to 6.9, almost 7, I'd probably be okay with any of those numbers. And then the other number I'm just going to call 0.75. If you call it 0.8, if you call it 0.7, whatever you call it, good to go. Okay? All right, so let's go down to this next set here. Okay? Example 2 here, we're going to look at the first one, and then we're going to have you think about the second one a second. And so the exact solutions, right? Exact solutions are like what we've seen in these pictures up here, where they intersected. Okay, and there's something I want you to think about with what's happening with this line compared to this line for this point, and then what's happening for this line compared to this line for that point. And we're going to come back to that as we kind of think about this graph. So where are their exact solutions, right? Well, you're going to look for where, obviously, are they equal, which is right here, right? Obviously. So what is that solution? Well, it's 3, 4.5. Right? And it is for this one too. And you kind of check it, right? Plug in 3 times 1.5 is 4.5. Type in 3, that's 7.5. 12 minus 7.5 is 4.5. So it works as their point of intersection, which is their solution, right? All right. So we're going to talk more about this when we learn how to use your graphing calculator a little better as well. And so for this one, right, where do they have solutions? Well, there's 5 different functions here. This right here is just the x values. This would be the y values for f, the y values for g, the y values for h, and the y values for m. That's how to read this, right? So where do we have equality here? Well, we can see right here that that has 2 1s in it. So for, well, maybe I said too much. Let's pause the video and see if you can finish my thoughts. And there is more than one answer. So put both. Try it out. Go. Okay, so I got a little ahead of myself there, obviously. You can see that this is 1, 1 and that this is 1, 1. And so how I would say it is, well, in row A, one of the solutions is f of x and g of x at 1, 1. right? And I look at my own notes and I say intersect at 1, 1. Well, that's kind of the point here. The intersection is the solution, right? But this is specific to two different graphs, right? This isn't like all of these are equal there. It's just those two graphs. And you could probably go through and see there's another one right there, right? And that is all, right? And so that's 3, 3 for both of those points. So I guess in row C, f of x, and that's a little and symbol. Sorry, I should have noted that more. And of course, m of x at 3, 3. And again, yes, they intersect, right? So really, 1, 1 is a solution for f of x equals g of x, and 3, 3 is a solution for f of x equals m of x. Okay. All right, so there's that. Let's flip it back to the back side. All right, so as you look at this first, the first thing I want you to see is just recognize, like read this through. Read it on your paper, read it through, and see if you can figure out what it's actually asking you to do. Like 10 seconds, you can press pause if you need to. I'm gonna actually kind of hold off for a second and just let you think about that. What is it asking me to do here? All right, so look at what it's saying, approximate solution. So again, what we're looking here for is the point of intersection between these two graphs. And these are just equations, right? If I think about the rough sketches of these, the first one I would start at -4 and I go up 6 over 1, and it would be a line kind of like that, right? And if I do 5x plus 2, let's use this other pen, I'd start at 2, right? And I'd go up 5 over 1. And I'd have two lines that look like they're parallel, but they're not. Sooner or later, they're going to kind of reach, and it's going to be quite a bit over here where they reach, right, off the graph even, okay? So from there, how can I do this using a calculator, and what does it mean, right? Like, we can literally solve this, and it'd be pretty easy, right? But I want you to see how this works when it looks like kind of on a table, like graphic thing, and then think about it graphically, right? So for this, all I want you to do is plug in all those values for x, for there, and there. Take a second, maybe press pause, and write these values down, or just write down the values. It's about what's next anyway. So when I plug in 2.5 into here, I get 2.5 times 6, which is 15, minus 4, which is 11. I don't need you to do that in your head. Just go into your calculator, 6, parentheses, 3.5, minus 4, and I'm just going to write down the rest of the values that I got when I plugged them into the calculator. And same thing here, 5 times 2.5 is 12.5 plus 2 is 14.5. And again, just plugging it into a calculator, you get these values. You can kind of see what's happening here. It's going up by 5. Well, that's because the slope is 5. This is going up by 6. It's because the slope is 6. That's the way it's supposed to work, right? All right, and so what we're looking for here is where are they equal? And if you think about the way these two graphs are going, look, this graph has a larger y value than that graph. Now this still has a larger value. This still has a larger value. This is just a little bit, but it still has a little larger. And then all of a sudden it's smaller. And then it's smaller, and so on, right? So think about that. Of course it is, right? If this is my graph, as this line kind of goes like this, and this line kind of goes like that, after they cross, right? This one's higher, 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 higher. And then all of a sudden, after they cross, it's lower, 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 lower. And then the other one gets to be bigger, right? That's what happens at a point of intersection. They change in value. And I was trying to say that even back here, right? Like, at this point, this function is greater than this function. And then they intersect, and then look, that function that was greater is now less than this function in terms of their y value, their maximum value, right? And this is higher, 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 and then they cross again, and look what happens. Now that becomes a lower y value than this one, right? At the same point, if I think about like that there compared to that there on the same x value, that's a way higher y value, right? So that's what happens in these graphs when they change value. So you knew that it was somewhere in here. So I'm going to kind of go that over here, and look, that's between 5.5. So I would probably guess around 6, because that's between those values, right? And it says, again, determine an approximate solution and justify why your solution is the best approximation, given in the table. Well, the x value is 6, and then I pick a y value, probably, somewhere between 29 and 35, right? So I don't know, like 32. And actually, that is the exact solution. That wasn't intentional, right? I would probably say x equals 6 is kind of the answer, or really any number between 5.5 and 6.5, because that's where we know they changed in value, right? So if you said 5.8 there, I would have been okay, because it says approximate, right? It doesn't, and SAT would be okay with that too, because it's saying that. And then check using your calculator, intersect key. Well, you can plug this in here. We're going to talk more about using the intersect key on the next lesson, actually, the calculator lesson. But basically, it's second. You're going to check it by going second, trace, 5, and then press enter 3 times. Again, you're going to see that on the next lesson, but maybe that's a little heads up, okay? And the point is, look, I mean, we know how to do this, right? This is a simple one. They're not always as simple, but for this one, I would just minus 5x over here and get x. I would add 4 over there, and get 6. And then I would plug 6 in to either of those equations, 30 plus 2, 36 minus 4, and get y to be 32. Okay. All right, so maybe pause it a second, find all these values, right? Plugging in -3, -2, all the way to 2 for each of these equations here. And see if you can find out where is their approximate solution. And this is going to be more approximate. It's not a great value. Thinking about x squared and x cubed, to make that be like 6, 32 doesn't really work out as well as I'd want, okay? All right, so let's plug it in. So again, in your calculator, when you plug things in, make sure you do it in parentheses, because if you type in -3 squared minus 5, it's going to tell you -14, when that is not the answer, because -3 squared is 9, right? -3 times -3. So when you plug things into your calculator, make sure you plug them in parentheses, even positives. You might as well just be in that habit so you don't make any mistakes. And even here, when I plug it in parentheses. So -3 squared is 9 minus 5 is 4. Again, I don't need you to do this in your head. Just plug in parentheses -2 squared minus 5, and you get -1 and -4 and -5. -4 and -1. And I'm even going to go so far as to say if I plug in number 3, I'm going to get 4 there. That's for something I'm trying to get at in a minute. For the g function, if I plug in, I'm going to do something really easy. Plug in 0 first, right? 3 times 0 plus 7, so I know that the 0 here is 7. I'm going to plug in 1. Now, again, I'm just doing this because I'm doing it in my head. I know I get 10 there. -1, though, think about that. That becomes a negative, plus that gives me 4. Now I'm just going to just type the rest in. This is -74. And this is 31. So you can, as you can imagine, for this x squared graph, it looks kind of like this, right? And an x cubed graph kind of looks like that. And it can have maybe a couple of intersections here, right? Well, let's just check and see, because sometimes it doesn't, right? Sometimes if it looks like that and it comes through like that, this is never going to catch that. This is never going to catch that. They're just going to have just that one intersection. So where would it be? Where would it be? Okay. If you've already written all this down, maybe press pause a minute and see if you can figure out where would the intersection be about. All right, so again, if you think about it the way we did last time, this is greater, this is still greater, this is less, right? Like when I compare these two, this is a greater value, this is a greater value, suddenly they swap. And where they swap then means that this, somewhere between those two numbers, is going to be a solution. It doesn't happen again. Let's see, this is less, this is less, this is less. Now I wonder if we kept going if they would catch up to each other. But for the values that we're asking for, an approximate solution would be somewhere between those two. So I would just say about x equals -1.5, right? Or really anything between -2 and -1. If you said -1.9 or -1.4, or any of those values would be correct. And then if I'm thinking of a y value, again, an approximate, now solution would be to plug in the x value and get a solution, right? So if I plug in -1.5 here, again, without a calculator, this is going to be kind of messy. But I can look on here, and see if it has to be between these two for x, then it has to be between these two and between these two for y. So between negative 17 and 4 is kind of a big range. But between negative 1 and negative 4, that's not so big of a range, right? So I'd probably say, I don't know, negative 2.5. Somewhere right kind of in the middle of those two numbers is what I would guess. And then when I go to plug it in, right, I can find the point of intersection, which, again, I'm going to show you quickly on here, but this is how you do it. I'm going to type in y equals, okay, the first equation, which is x squared minus 5. I'm going to type in the second equation, which is 3x to the third plus 7. And I'm going to find the point of intersection by pressing graph here. I see that graph. I see that graph, and I can see kind of where it was, right? Well, there's a way that we can do this, right? We go second, we got to go to graph. It just graphed it second. That's not what I wanted. Math. What am I doing here? All right, we got our graph. So, second, trace, right there. You see where it says trace because we want the calculator option because we want to calculate the intersection. So I press 5. So again, second trace 5 gets me there. And all I got to do is just move this cursor over by the other point right there, right? And I'm just going to go enter, enter, enter. And look at that. It says negative 1.48 and negative 2.79. So I'm going to say pretty much that, right? It's negative 1.4837, comma negative 2.798. And that was the point. Okay? So there we go. There's our lesson. Your homework is to do the 1-7 day 2 worksheet, and then also to be working through the how to use your calculator document. More to come on that video shortly. Have a good day.